Hi, this is Alex from devstories.eu, Mastering Modern Pandas, Episode 3 of 8. You load a dataset with a few million rows, and suddenly your memory usage spikes through the roof. The numbers are fine, but the text columns and the missing values are quietly destroying your RAM. The fix is a fundamental shift in how Pandas stores data, and that is exactly what this episode is about, the PyArrow engine room. If you have heard of Apache Arrow, you might think it is strictly for big distributed systems like Spark or Hadoop. It is not. Arrow is now a first-class native memory format and execution engine right inside Pandas. For years, Pandas relied entirely on NumPy. NumPy is incredibly fast for dense numerical calculations, but it has a massive blind spot regarding missing data. NumPy does not have a native concept of a missing integer or a missing Boolean. If you have an integer column and a single value is missing, Pandas has historically been forced to convert the entire column to floating point numbers just so it can use the not a number marker. This changes your data types, ruins exact matches, and consumes more memory. PyArrow solves this using a validity bitmap. Instead of changing the data type to accommodate a missing value, Arrow keeps your integers as integers. It adds a hidden, highly compressed array of ones and zeros alongside your data. A 1 means the value is valid. A 0 means it is missing. Your data type stays intact, and tracking the missing values costs almost zero memory. Here's the key insight. The influence of the memory savings is even more extreme when dealing with text. Traditionally, Pandas store strings using the NumPy object data type. This means the column doesn't actually hold your text. It holds memory pointers. Each row points to a standard Python string object scattered somewhere else in your computer memory. If you have 10 million rows of text, you have 10 million pointers and 10 million separate string objects. The memory overhead is staggering, and iterating through them is terribly slow. PyArrow changes the architecture entirely. When you set your Pandas columns to use a PyArrow string data type during your read step, the text is stored in a single contiguous block of memory. The column just keeps track of the byte offsets. It records exactly where each word starts and stops in that large continuous block. Picture a high cardinality dataset. You have a column of user agent strings or unique transaction IDs. Many of the rows are empty. If you read this into Pandas the traditional way, it defaults to a NumPy object array. Now, tell Pandas to use the PyArrow engine instead by explicitly assigning a PyArrow-backed string data type during your read step. Instantly, the memory footprint drops, often by 50% or more. The improvement goes beyond RAM limits. Because the data is now packed tightly together in a structure built for analytics, string matching operations accelerate. If you run a regular expression search across that column, the Arrow engine processes the raw bytes directly at the system level. It completely bypasses the slow Python object overhead. You get integer columns that actually stay integers when data is missing, and string operations that don't choke your hardware. If you process text or messy data, relying on the NumPy object array is obsolete. Using PyArrow-backed data types is the single fastest way to make a heavy Pandas pipeline instantly lighter. Thanks for listening. Happy coding, everyone.